Good day, everyone. My name is Melissa A. Quadrado, and I am student 28. And I will discuss to you the open channel flow, the definition, and also the uniform flow. Do you mean by open channel flow? Open channel flow is defined as fluid flow with a free surface open to the atmosphere. And it is a flow of liquid, basically water, in a conduit with a free surface, that is surface on which pressure is equal to local atmospheric pressure. And the examples of these include streams, rivers, and culverts, not flowing full. And this open channel flow assumes that the pressure at the surface is constant and the hydraulic grade line is at the surface of the fluid. And there are classification of open channel flows. Open channel flows are characterized by a presence of a liquid gas interface called the free surface. And the first classification of open channel flow is natural flows. And this includes rivers, creeks, floods, and others. And the second one is the human-made systems. And this includes freshwater aqueducts, irrigations, sewers, drainage ditches, and others. And there are kinds of open channel. These are the canal, flume, chute, drop, culvert, and open flow tunnel. Canal is usually a long and mild slope channel built in the ground. This is a long, man-made strip of water used for irrigation or boat access to a bigger body of water. And the next is the flume. It is a channel usually supported on or above the surface of the ground to carry water across a depression. It is a human-made channel for water in a form of an open decline gravity chute whose walls are raised above the surrounding terrain. Chute is an incline is a channel having a steep slopes, and it is a inclined channel as a tube or a shaft for conveying water, grain, and etc. to lower lower level. And the next one is a drop. It is similar to a chute, but the change in elevation is affected in a short distance. Next one is a culvert. It is a covered channel flowing partly full, which is installed to drain water through highway and railroad embankments. Uh, it is a structure that allows water to flow under the road or similar obstruction from one side to the other. Typically impeded so as to be surrounded by soil, a culvert may be made from a pipe or reinforced concrete or other materials. And the next one is the open flow tunnel. Open flow tunnel is comparatively long covered channel used to carry water through a hill or any obstruction on the ground. And the next one, yeah, I will discuss to you also the geometric elements of channel section so that we will understand the formula. The depth of flow y is the vertical distance of the lowest point of a channel section from the free surface. See, you can see the y there in the illustration. And also the depth of flow section D is the depth of flow normal to the direction of flow, and the theta is the channel bottom slope, where D is calculated as D is equal to y cosine theta. And for mild slope, channels Y is approximately equal to D. The tapped width D is the width of the channel section at a free surface. And the water area A is a cross-sectional area of the flow normal to the direction of flow. And the weighted perimeter P is the length of the line of intersection of the channel weighted surface with cross-sectional plane normal to the direction of flow. And the hydraulic radius R is a ratio of the water area to its weighted parameter, which is R is equal to area over P, or area over parameter. And lastly, the hydraulic depth D is equal to is the ratio of the water area to the tapped width, or D is equal to A over D. Next is the uniform flow. What is uniform flow? Uniform flow means fluid flowing into different parts of the fracture surface with equal flow velocity per unit area. And uniform flow type curves applicable to those wells connect natural vertical fissures. And flow in open channels is classified as being uniform or non-uniform depending upon the depth of Y. And the depth in uniform flow is called normal depth Yn. And uniform depth occurs when the flow depth and thus the average flow velocity remains constant. And the common and long straight run average flow velocity is called uniform flow velocity V sub O. And the uniform depth is maintained as long as the slope, cross-section, and surface roughness of the channel remain unchanged. During uniform flow, the terminal velocity reached and the head loss equals to the elevation drop. And these are the equations can use in solving the open channel flow. These are the Cheesy equation, Darcy-Weisbach equation, and also the Manning equation. Cheesy equation introduced by a French engineer Antoine Cheesy in 1768 while designing a canal for the water supply system of Paris. And the formula is V is equal to C the square root of R sub H of times multiplied by S sub F, where the C there is the Cheesy coefficient, and it is and the C is greater than 260 the square root of M over S, and smaller than 150 the square root of M over S, where 60 is for rough and 150 is for smooth. Also a function of R, or like F in Darcy-Weisbach. The second one is the Darcy-Weisbach equation. And the formula is head loss from the final is equal to F times L over D times V squared over 2G. And the important note here in uniform flow, SF is equal to SO, or channel bed slope. And in Manning equation for uniform flow, we can use the equation V, or velocity, is equal to 1 over Manning's roughness coefficient N times hydraulic radius R to the power of 2/3 times channel bed slope S sub O to the power of 1/2. And the discharge is equal to Q is equal to V times A, or Q discharge is equal to 1 over Manning's roughness coefficient N times area times radius to the power of 2/3, and channel bridge slope S sub O to the power of 1/2. And note that in Manning equation, it is dimensionally non-homogeneous and it is very sensitive to its roughness coefficient n. And these are the values of Manning's roughness coefficient accordingly sa each of its materials. And here is an example. A trapezoidal channel has a base with P is equal to 6 meter and a side slopes 1h is to 1p. The channel bottom slope is S sub O is equal to 0.0002 and the Manning roughness coefficient is N is equal to 0.014. Compute the depth of uniform flow if discharge is equal to 12.1 cubic meter per second and the state of flow. That solution is by using the Manning's equation for uniform flow, we can get the Q is equal to area over N times R to the power of 2/3 the square root of S sub O, and substitute there the equation of getting the area and also in the parameter, and we have also the given S sub O is equal to 0.0002, N is equal to 0.014, and Q is 12.1 cubic meter. By substituting this given, we can get the what do you call that one? Sorry, wait. The depth of uniform flow. And by trial and error, we can get the y sub O is equal to 1.5 meter. And the state of flow, Fr, is equal to average velocity over the square root of G times depth, hydraulic depth, where depth is equal to area over tapped width. And the tapped width is equal to B is plus 2 times y sub O. And by getting the area, the tapped width, and the diameter, the depth, we can get the Fr, state of flow, is equal to 0.307, which is less than to 1, and it is subcritical. And that would be all. Thank you.